Hey everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. And today's video, we are going to check out this Linux privilege escalation room inside of TryHackMe. We are continuing on with the junior penetration tester path, privilege escalation module, and let's see what it says. Learn the fundamentals of Linux privilege escalation from enumeration to exploitation. Get hands-on with over 8 different privilege escalation techniques. Let's go ahead and dive into it. Task 1. Introduction. Privilege escalation is a journey. There are no silver bullets, and much depends on the specific configuration of the target system, the kernel version, installed applications, supported programming languages, other users' passwords are a few key elements that will affect your road to the root shell. This room was designed to cover the main privilege escalation vectors and give you a better understanding of the process. This new skill will be an essential part of your arsenal whether you are participating in CTFs, taking certification exams, or working as a penetration tester. Task number 2. What is privilege escalation? What does privilege escalation mean? At its core, privilege escalation involves going from a lower permission account to a higher permission one. More technically, it's the exploitation of a vulnerability, design flaw, or configuration oversight in an operating system or application to gain unauthorized access to resources that are usually restricted from the users. And you can see that in this infographic here, going from a regular user to the super admin user. Why is it important? It's rare when performing a real-world penetration test to be able to gain a foothold initial access that gives you direct administrative access. Privilege escalation is crucial because it lets you gain system administrator levels of access, which allows you to perform actions such as the following here: resetting passwords, bypassing access controls and to compromise protected data, editing software configurations, enabling persistence, changing the privilege of existing or new users, execute any administrative command. And let's continue on to task number 3 here. I already got the machine fired up here. And it says you can SSH into it as well using Karen and password 1 with the capital P. All right, enumeration is the first step you have to take once you gain access to any system. You may have accessed the system by exploiting a critical vulnerability that resulted in root level access or just found a way to send commands using a low privilege account. Penetration testing environments, unlike CTF machines, don't end once you gain access to a specific system or user privilege level. As you will see, enumeration is as important during post-compromise phase as it is before. And the first thing we're going to talk about here is going to be host names. Let me clear all this stuff out of here. And if you type in host name, you figure out what the host name is. Maybe you can find out some potential information about what the host business purpose is, right? You can't really see much from this one. All it says is Wade 7363. So maybe Wade is a user or an employee at this particular company, what have you. But let's go ahead and read what they have here. The host name command will return the host name of the target machine, although this value can easily be changed or have a relatively meaningless string, such as following here, this is Ubuntu, then a bunch of numbers. In some cases, it can provide information about the target's system's role within the corporate network. Example with the SQL prod 1 for a production SQL server. And you can use this one, uname-a. So let's go ahead and type that one in too. Uname-a will print system information giving us additional detail about the kernel used by the system. This will be useful when searching for any potential kernel vulnerabilities that could lead to privilege escalation, right? So you can do some Googling and see if there's any vulnerabilities related to this particular version of the kernel. And it says proc version. The proc file system, proc FS, provides information about the target system processes. You will find proc on many different Linux flavors, making it an essential tool to have in your arsenal. Looking at proc version may give you information on the kernel version and additional data such as whether a compiler, an example would be the GCC, is installed, right? So look, first off, let's see where we're at. All right, so let's do this. And it says proc version. So I'm assuming they want us to cat this. So let's do proc like so, and then version. And there we have it. You can see some information here. Linux version, yada, yada, yada. GCC version 4.8.2. Let's continue on here. And we're going to talk about Etsy issue. Systems can also be identified by looking at the etc issue file. This file usually contains some information about the operating system, but can easily be customized or changed. While on the subject, any file containing system information can be customized or changed. For a clear understanding of the system, it is always good to look at all of these. So let's go do the same thing here, right? Oh, we can't up arrow in here. All right, they want us to do it the long way. So let's go ahead and do a cat and then etc issue. There we go. Ubuntu 14.04 LTS. And PS command. The PS command is an effective way to see the running processes on a Linux system. By typing PS on your terminal, will show processes for the current shell. The output of the PS process status will show the following. You got the PID, you got the TTY, time, amount of CPU time used by the process. This is not the time this process has been running for. CMD, the command or executable running, will not display any command line parameter. The PS command provides a few useful options. You got the PS-A, view all running processes, and PS-AXJF, view process tree. See the tree formation until PS-AXJF is run below. So let's take a look at this little snippet here. That's what it looks like. All right, and then you got PSAUX. The AUX option will show processes for all users, which is A, display the user that launched the process, which is U, and show processes that are not attached to the terminal, which is X. Looking at the PSAUX command output, we can have a better understanding of the system and potential vulnerabilities. So try that out if you choose to do so. I'm not going to run on here because it's going to take up a lot of the screen here, and I know we got some questions down here to answer. env. The env command will show environmental variables. Right, so you can take a look at this snippet real quick. Looks like the home here, and looks like Alper is the name of a user on this machine, possibly, right? That's their home folder, and they're looking, they're using Z shell apparently, according to that, and it says their path is going to this game's file or whatever. And that's about it that they have highlighted here. So let's continue on here. The path variable may have a compiler or a scripting language. Example would be Python. That could be used to run code on the target system or leverage for privilege escalation. And then you got sudo-l. The target system may be configured to allow users to run some or all commands with root privileges. The sudo-l command can be used to list all commands your user can run using sudo. ls, one of the common commands used in Linux, probably ls. While looking for potential privilege escalation vectors, please remember to always use the ls command with the -la parameter. The example below shows how the secret.txt file can easily be missed using the ls or ls-l command. So they want us to use -la with ls, all right? So be sure to remember that. And if you take a snippet or take a look at the snippet here, and it shows that here, see it's in this hidden file location here. And you got the ID command. It says ID command will provide a general overview of the user's privilege level and group memberships. It is worth remembering that the ID command can also be used to obtain the same information for another user as seen below. So if you do ID Frank, it'll tell you information about that particular user. All right. etc passwd. Reading the etc passwd file can be an easy way to discover users on the system, and that's typically what I would do, right? Log into the machine, find out host name, information, hit ID, see maybe sudo L to list out the particular privileges your user can do with sudo, if they can do that. And then take a look at this etc passwd file to figure out what real user counts are on here, right? So if you take a look at this file here, it doesn't appear to have any besides root from what I can see here. All right, so if you do, if you cat the file, it's cat etc and then pass wd. There you go. So we have users in here, right? We got Matt and we got Karen down there. And let's go ahead and continue on. Let's see here. Well, root's going to be on all systems, right? Obviously. But let's see. While the output can be long and a bit intimidating, it can easily be cut and converted to a useful list for brute force attacks. And you could do that using this here, right? They use the cut command here. And what the delimiter is going to be this colon here and then -F1. So you can use that In a particular brute force attack, if you choose to do that, like password spraying or something like that, remember that this will return all users, some of which are system or service users that would not be very useful. Another approach could be to grep for home, as real users will most likely have their folders under the home directory, and that's what this looks like here, right? You got Alper and you got Frank. And history. Looking at earlier commands with the history command can give us some idea about the target system, albeit rarely, have stored information such as passwords or usernames. Ifconfig. The target system can be a pivoting point to another network. The ifconfig command will give us information about the network interfaces on the system. The example below shows the target system has three interfaces: ETH0, TON0, and TON1. Our attacking machine can reach the ETH0 interface, but cannot directly access the other two networks. So if you take a look here, this is what they're talking about. You could do that as well. Ifconfig is kind of like, I guess, the old command. I think the newer one is like IPA, right, to list out some network information. Ifconfig might still work on Linux boxes. I usually do IPA or something. This can be confirmed using the IP route command to see which network routes exist. So if you do IP route, it'll show you exactly what they're talking about here. All right. And netstat. Following an initial check for existing interfaces and network routes, it is worth looking into existing communications. The netstat command can be used with several different options to gather information on existing connections. You got netstat-a, show all listening ports and established connections. Netstat-at or netstat-u can also be used to list TCP or UDP ports respectively. Netstat-L lists ports in listening mode. These ports are open and ready to accept incoming connections. This can be used with the T option to list only ports that are listening using the TCP protocol below. And this example of what that looks like. All right, netstat-S list network usage statistics by protocol shown below. This can also be used with the -T or -U options to limit the output to a specific protocol. So take a closer look here. That's what that looks like here. All right. Netstat-TP lists connections with the service name and the PID information, right? The process ID. That's what that looks like here. All right. We can see the PID program name. Column is empty as this process is owned by another user. Below is the same command run with root privileges, reveals the information as 2641-NC, which is netcat. So take a look at this here. It says PID/program name right there. All right. And netstat-I shows interface statistics. We can see below that ETH0 and TON0 are more active than TON1. This is what that looks like here. The netstack usage will probably see most often in blog posts, write-ups, and courses is netstat-A and O, which could be broken down as follows: -A, display all sockets; -N, do not resolve names; -O, display timers. And that's what that looks like here. All right. Find command. Searching the target system for important information and potential privilege escalation vectors can be fruitful. The built-in find command is useful and worth keeping in your arsenal. Below are some examples for the find command. Find files, right? I'm not going to read all this here, so be sure to pause the video and read through here. You got find, and then dot dash name flag1.txt. Find the file named flag1.txt in the current directory. And this other one says find the files names flag.1 or sorry flag1.txt in the home directory, etc., etc. Find files with 777 permissions, which is files readable, writable, and executable. Find executable files. Find all files for the user Frank and are under home, and then you have the rest there. This command can also be used with the plus and minus signs to specify a file that is larger or smaller than given size. So if you take a look here, find, and then got the size here, 100 megabytes looks like. All right. The example above returns files that are larger than 100 megabytes. It is important to note that the find command tends to generate errors, which sometimes makes the output hard to read. This is why it would be wise to use find command with -type f, and then you can see the rest there to redirect errors to the dev null and have a clearer or cleaner output shown as below, right? So you don't have all those errors and stuff cluttering up the screen. Folders and files that can be written to or executed from. I'm not going to read all this here, so be sure to take your time and read through here. Find dash writable dash type D. Send that to send errors to dev no. Find world writable folders. Find world writable folders, etc., etc. The reason we see three different find commands that could potentially lead to the same result can be seen in the manual document. As you can see below, the perm parameter affects the way find works. So you can take a look at that here. All right, find and then dash perm dash ox dash type d, and then you see the rest there. Find world executable folders. Find development tools and support languages. Right, so looking for Perl, Python, and GCC. Find specific file permissions. Below is a short example used to find files that have the suid bit set. The suid bit allows the file to run with the privilege level of the account that owns it rather than the account which runs it. This allows for an interesting privilege escalation path we will see in more detail on task 6. The example below is given to complete the subject on the find command, right? So that's what that looks like here. Find files with the suid bit, which allows us to run the file with a higher privilege level than the current user. General Linux commands, as we are in Linux realm, familiarity with Linux commands in general will be very useful. Please spend some time getting comfortable with commands such as find, locate, grep, cut, sort, etc. All right, so question and answer time. What's the host name of the system? Well, we saw up above using host name, right? It's Wade7363. What is the Linux kernel version of the machine? And we found that with right here. If you cat this proc version, you can see that right here, this 3.13, etc., etc. And what Linux is this? And that's Ubuntu 14.04. We did that by catting the etc issue file. What version of the Python language is installed on the system? So let's go ahead and try to find that here. And if you scroll back up to find Python, right, you got to use find. And let's see if this lets me copy and paste. So, all right, so let's go ahead and clear all this out like so and paste this in here. I don't know how long this is going to take. Oh, there's a lot. Holy moly. Okay. Let's see what version of Python language is installed. So now I figured there was an easy way to do this, right? So it's going to be Python dash capital V, and it'll give you the version of Python on the machine. So let's go ahead and copy this out of here like so. Paste it. There we go. And it says what vulnerability seems to affect the kernel of the target system. All you got to do is basically Google this right here, right? Once you do a Google search on it, you can come back and see various different results. This particular one I saw was this Linux kernel exploit on this GitHub page on the it says sec wiki, right? And this is going to be CVE 2015-1328. So that's what I put down as the answer. Now let's continue on to task number 4, automated enumeration tools. And let's see what they got for us. Several tools can help you save time during the enumeration process. These tools should only be used to save time, knowing they may miss some privilege escalation vectors. Below is a list of popular Linux enumeration tools with links to their respective GitHub repositories. The target system's environment will influence the tool you will be able to use. For example, you will not be able to run a tool written in Python if Python is not installed on target system. This is why it would be better to be familiar with a few rather than having a single tool to go to, right? They got linpiece in here, lin, enum, les, or less, which is Linux exploit suggester, Linux Smart Enumeration, and Linux Priv Checker. So be sure to check out all these, right? Maybe there's something you can possibly use in a CTF or in the real world. Install and try a few automated enumeration tools on your Linux distribution. So be sure to try that out. Hey everybody, just a quick little blurb here. As you can see here, most people that view my channel are not subscribers. If you're new here, please consider subscribing to the channel. If you're enjoying the video, please consider hitting the like button. It helps get me in the algorithm, helps spread the good word out there, helps bring more people and increase our glorious community here. All right, I'm all about helping out others. I know what it's like to come up in cybersecurity or even try to get into cybersecurity and not knowing where to look. I'm just having this channel up so I can help out other people. All right, that's all I got. Task 5, Privilege Escalation, Kernel Exploits. Now I have started up the attack box and I am currently SSH'd into the target machine to make things easier because you have to transfer some files over in order to run these. All right, we'll show that here in a second. But let's go ahead and continue on what they have for us here. Privilege escalation ideally leads to root privileges. This can sometimes be achieved simply by exploiting an existing vulnerability, or in some cases by accessing another user account that has more privileges, information, or access. Unless a single vulnerability leads to a root shell, the privilege escalation process will rely on misconfigurations and lacks permissions. The kernel on Linux systems manages the communication between components such as the memory on the system and applications. This critical function requires the kernel to have specific privileges. Thus, a successful exploit will potentially lead to root privileges. The kernel exploit methodology is simple. Number one, identify the kernel version, which we've already done. Number two, search and find an exploit code for the kernel version of the target system. Number three, run the exploit. Although it looks simple, please remember that a failed kernel exploit can lead to a system crash. Make sure this potential outcome is acceptable within the scope of your penetration test engagement before attempting a kernel exploit. Now, if this is the case, you might want to reach out to your contact at the target organization, the client organization, right, and get some approval from them before you start running stuff like this and crash a server that could be of critical importance to the client, right? You don't want to cause a big outage or anything like that. It says research sources. Number one, based on your findings, you can use Google to search for an existing exploit code. Number two, sources such as the following here: Linux kernel, CVEs.com can also be helpful. Three, another alternative would be to use a script like LES, Linux exploit suggestion. But remember that these tools can generate false positives. Report a kernel vulnerability that does not affect the target system, or false negatives. Not report any kernel vulnerabilities, although the kernel is vulnerable. Hint/notes. Number one, being too specific about the kernel version when searching for exploits on Google, ExploitDB, or SearchSploit. Two, be sure to understand how the exploit code works before you launch it. Some exploit codes can make changes on the operating system that would make them unsecured if further use or make irreversible changes to the system, creating problems later. Of course, these may not be great concerns within a lab or CTF environment, but these are absolute no-nos during a real penetration testing engagement. Number three, some exploits may require further interaction once they are run. Read all comments and instructions provided with the exploit code. Number four, you can transfer the exploit code from your machine to the target machine using the following: the simple HTTP server, Python module, and wget respectively. All right, which I've already have that set up here. Now, first thing you want to do is create this or go to this TMP folder here, right? So you can transfer the files. And as you can see, I've already done some stuff in here, right? I got this Linux exploit suggester downloaded here, right? I also have linps in here as well. So I've already transferred linps over, but let's transfer this les.sh file over. All right, now I have this server set up here, right? Already running here, and C Python 3-M for the module, then http.server, and it's running on port 9000. It's over 9,000. Anyway, let's go ahead and continue here. And I'm going to use wget on the target box, okay? And this is the location of this particular file.sh. There we go. All right, so let's go ahead and clear all this out and do ls. And there we go. It's ready to go. Now, before you do anything, you need to do a chmod on it, right? Dash plus x makes executable les.sh. There we go. Now to run this, you're gonna do a dot / and les.sh, and let's see if it works. All right, so it's going through and it's choosing a ton of possible exploits to choose from. There's quite a few in here. All right, now the better thing to do would probably just to do a Google search on the kernel and try to find out something there. All right, so there's a bunch of stuff to sift through here. Kernel version 3.13.0. All right, so let's try. You can run linps as well. So let me clear all this stuff out of here, and let's do. Make sure to get the file name correct. Okay. Dot / again. All right, linps.sh. All right, now go through and run and come up with some more information on things. But let's flip forward and come back to the actual exploit code and everything, and then trying to find this file or flag.txt file. Okay, now Assuming that you are using the information we've already discovered about the kernel version, do some Googling on it, you'll come across a exploit code out there. And the one I'm using is going to be here on exploit.db. All right, I've already downloaded the file and I've already transferred the file from the attacker machine over to the target box here. It tells you how to use this inside of this file here. If you look at the comments section here, it tells you how to use it. All right, so let's go ahead and minimize this here, and I've already ran it. Now you have to use GCC to compile this file. Okay. Now the C file is this hack.c, and you can see that it's on the box here. I did the ls, right, and then GCC to compile it, and then output file is this hack. Ran it here with the dot/hack. It went through, did its thing here, and now I am root. As you can see that by that pound sign, you can also do ID. Right. Let's do who am I root. So there you go. Now we are root. Now all we need to do is find this particular flag. And if we do ls, let's cd back into root first, the root folder. Do ls on here, and let's see. Remember now we can take a look. Let's take a look at this home directory. Okay, see what users in here in this mat folder. Take a look at this mat folder. Ls on that, and there's the flag file. So let's do a cat flag one.txt. You can also use the find command to find this as well. But there's our flag that we needed here, and we are going to continue on with the next task here, which is going to be task number 6. Now, be careful because I tried to use the file from GitHub and it was not working. I tried compiling it. I even tried downloading the compiled file that was already on there, and none of it was working. So use the one from exploit.db. Otherwise, you might run into some issues like I did. But let's go ahead and continue on with task number 6 here. And it says privilege escalation sudo. The sudo command by default allows you to run a program with root privileges. Under some conditions, system administrators may need to give regular users some flexibility on their privileges. For example, a junior SOC analyst may need to use nmap regularly, but would not be cleared for a full root access. In this situation, the system administrator can allow this user to only run nmap with root privileges while keeping its regular privilege level throughout the rest of the system. Any user can check its current situation related to root privileges using the sudo-l command to list out your privileges, right? And this GTO bins.github.io is a valuable source that provides information on how any program on which you may have sudo rights can be used. This is leverage application functions. Some applications will not have a known exploit within the context, such an application you may see is the Apache 2 server. In this case, we can use a hack to leak information leveraging a function of the application. As you can see below, Apache 2 has an option that supports loading alternative configuration files, which is -f. Specify an alternative server configuration file or config file, and that's what that looks like here. Okay, it says loading the Etsy shadow file using this option will result in an error message that includes the first line of the Etsy shadow file. Leverage LD underscore preload. On some systems, you may see the LD underscore preload environment option. So it looks like here. All right. And it says LD underscore preload is a function that allows any program to use shared libraries. This blog post, so check out that blog post, will give you an idea about the capabilities of LD preload, and the env keep option is enabled. If the environable keep option is enabled, we can generate a shared library which will be loaded and executed before the program is run. Please note the LD preload option will be ignored if the real user ID is different from the effective user ID. The steps of this privilege escalation vector can be summarized as follows. Step 1, check for LD preload with the env keep option. Number 2, write a simple C code compiled as a share object .so extension file. Number 3, run the program with sudo rights and the LD preload option pointing to our .so file. The C code will simply spawn a root shell and can be written as follows. And this is what it looks like here. We can save this code as shell.c and compile it using GCC into a shared object file using the following parameters, using these parameters here. All right, this is what it looks like here. We can now use this shared object file when launching any program our user can run with sudo. In our case, Apache 2, find or almost any of the programs we could run with sudo can be used. We need to run the program by specifying the LD preload option as follows, right? So that's what it looks like there. This will result in a shell spawn with root privileges. All right. All right, answer some questions here. All right. Now, it says how many programs can the user can run on the target system with the sudo rights. Now, to find that information, use sudo-l, and we can see that we can use find, less, and nano. Second question is, what is the content of flag2.txt file? Now, more than likely, you have to escalate privileges, something in that order, or what have you. All right. Now, in order to find this, you can go to the website they listed earlier, this GTFO bins, and type in that information. Right. So this particular one, we're going to use less. We're looking at less here, and we can do less, and then the path of the file, right? And then do this uh, this bang symbol bin, and then sh at the end of that. So let's try this less etsy shadow, like so, and then at the end here, let's go ahead and paste in this. See if we can break out of it. And there we go. See, now I'm root. Who am I? All right, there you go. So now we're root, and let's find this flag file. First, let's see where we're at. Okay, we're in root. Let's do ls, and let's cd into the home directory. Do ls there. Ubuntu, so cd into Ubuntu, like so. Ls there, flag. So let's go ahead and cat that bad boy and see the file contents. And there's our flag here. So let's go ahead and grab that and insert that information here. And next one says, how would you use nmap to spawn a root shell if your user had sudo rights on nmap? The same thing here. Go back to that website, GTFO bins. All right. So let me back out of this here. Type in nmap and go to this option here, sudo, right? And take a look here. It says if the binary is allowed to run as superuser by sudo, it does not drop the elevated privileges and may be used to access the file system, escalate, or maintain privilege access. Input echo is disabled, and this is the interactive mode available on versions 2.02 to 5.21 can be used to execute shell commands. This here, the sudo nmap dash dash interactive to spawn that shell, and it says what's the hash of Frank's, and we saw that earlier. Um, well, since we're root, we might as well just cat the file. So there is the hash, and it's very long here. So let's go ahead and grab it and copy this over like so. Right now, when you're copying and pasting over this hash, be sure to get rid of these colons at the end of it. All right. So the last thing on here is going to be 7. Otherwise, it's not going to accept the answer. All right. Task number 7, and we're going to talk about privilege escalation with these SUIDs. So first thing, let's go ahead and kill this target machine and start up the new one. And let's read through some of this. Much of Linux privilege controls rely on controlling the users and file interactions. This is done with permissions. By now, you know that files can have read, write, and execute permissions. These are given to users within their privilege levels. This changes with SUID, which is set user identification, and SGID, set group identification. These allow files to be executed with the permission level of the file owner or the group owner, respectively. You will notice these files have an S bit set showing their special permission level, and that's what this looks like here. All right, to find that using the find command again, we'll list the files that have SUID or SGID bits set. So you can take a look at the snippet here. Okay. A good practice would be to compare executables on this list with the GTFO bins, right? The website we were just on earlier. Clicking on the SUID button will filter binaries known to be exploitable when the SUID bit is set. You can also use this link for a pre-filtered list, all right? And that's what that looks like here. All right. The list above shows that Nano has the SUID bit set. Unfortunately, GTFO bins does not provide us with an easy win. Typical to real-life privilege escalation scenarios, we will need to find intermediate steps that will help us leverage whatever minuscule finding we have. All right. Note, the attached VM has another binary with SUID other than Nano. The sudo bit set for the Nano text editor allows us to create, edit, and read files using file owner's privilege. Nano is owned by root, which probably means that we can read and edit files at a higher privilege level than our current user has. At this stage, we have two basic options for privilege escalation: reading the etc shadow file or adding our user to etc passwd. Below are simple steps using both vectors reading the etc shadow file. We see the nano text editor has sudo bit set by running this following command here. And it says nano etc shadow will print the contents of the etc shadow file. We can now use the unshadow tool to create a file crackable by John the Ripper. To achieve this, unshadow needs both etc shadow and etc passwd files. You can see there here. The unshadow tool usage can be seen below. That's how you use it. All right. With the correct word list and a little luck, John the Ripper can return one or several passwords in clear text. For a more detailed room on John the Ripper, you can check out this room here. The other option would be to add a user that has root privileges. This would help us circumvent the tedious process of password cracking. Below is an easy way to do it. We need the hash value of the password we want the new user to have. This can be quickly done using the OpenSSL tool on Kali Linux. That's what it looks like here. All right. We will then add this password with a username to the etc passwd file. And that's what that looks like here, this hacker account. Once our user is added, please note how root bin bash was used to provide a root shell. We will need to switch to this user and hopefully should have root privileges. There you go. They did that with SU, right? Switch user to hacker. Now it's your turn to use the skills we were just taught to find a vulnerable binary. All right, and we're gonna answer these questions down below. So let's go ahead and try this out. Give it a shot and then come back to the video for the solution. First question says, which user shares the name of a great comic book writer? Now, what you want to do is cat the etc passwd to see which users are on here, and the one that stands out is going to be this Jerry Conway. So that'll be the information for that one. And next one says, what is the password of user 2? Now, in order to get to this one, we have to escalate the privileges. Okay, first off, you go in and try to figure out um, which one has that sudo set for it, right? And you can do that with this find command here, right? Went through and did that, and finally figured out which one it was, and it turned out it's going to be this base 64. And so if you move over to this GTFO bins website and you look for the sudo information in here, there's one that I use. This is file read. All right. So basically, you're going to replace file to read with the etc shadow as I showed right here. Okay, so it went through, did its thing, and got all the hashes for everything, all the users on here, right? Jerry Conway, user 2, and Karen. All right, so in order to get to this password, you can do it the John the Ripper way or maybe some other way. But anyway, the way I did it was I went to this hashes website and I'm gonna plug in this information above, right? Copy and pasted the hashes for each username I want to get the password for. So I'm gonna hit submit and search. And it says that 3 hashes were checked, 1 found, 2 not found. Okay, so the one that was found was the user 2 hash, and it says password is password 1 with capital P. All right, now I'm not sure what's going on with these, but anyway, I'm sure you can figure out what these are with the John the Ripper, but the easy way to do this is with this hashes website to find the user 2. All right, so now I'm going to clear all this information out of here. And I'm gonna switch user to user 2. All right, password what's capital P 1 like so, and then who am I? There we go. And it says what is the content of flag 3? Well, first off, let's check our permissions with sudo -l, and let's see if we can actually run this. All right, so that's not gonna work. Let's cd into home, do an ls ubuntu. I guess Ubuntu may be the one we're looking for, but let's see if we can even get into this folder. All right, cool. flag 3, like so, .txt. Permission denied. Okay, we need to get this Ubuntu user apparently. So let's go ahead and try to crack this password with John the Ripper. Okay, apparently you don't need to do that. Now, from that suite information that we found before, if it reads data from files that may be used to do privileged reads or disclose files outside of a restricted file system. All right, so we can bypass all that. Don't even need to use John the Ripper or anything like that. So all you got to do is replace the file to read with this particular location of the flag. Okay, and that's what I did here, and I got the contents of that flag file. So let's go ahead and plug that in there, and let's continue on to task number 8. All right, now while that's loading, let's read through all this. Another method system administrators can use to increase the privilege level of a process or binary is capabilities. Capabilities help manage privileges at a more granular level. For example, if the SOC analyst needs to use a tool that needs to initiate socket connections, a regular user would not be able to do that. If the system administrator does not want to give this user higher privileges, they can change the capabilities of the binary. As a result, the binary would get through its task without needing a higher privileged user. The capabilities man page provides detailed information on its usage and options. We can use the get cap tool to list the enabled capabilities, and that's what that looks like here. Remember, they got this dev null again to get rid of all the errors that would happen to appear here. When run as an unprivileged user, getcap-r will generate a huge amount of errors, so it's good to practice to redirect error messages to dev null. Please note that neither Vim nor its copy has the suid bit set. This privilege escalation vector is therefore not discoverable when enumerating files looking for suid. There you have it. GTFO bins has a good list of binaries that can be leveraged for privilege escalation if we find any set capabilities. We notice that Vim can be used with the following command and payload. All right. This will launch a root shell as seen below. All right. And answering question time. All right. So go ahead and try to find the solutions to this. If not, then come back to the video and we'll just step through all of these together. So let's answer some of these questions. It says complete the task described above on the target system. So go through that and click complete whenever you're finished with that. How many binaries have set capabilities? And using that command from above, using get cap, right? We can see that there's 6 of them listed out here. And what other binary can be used through its capabilities? And we can see the other one's view. You got Vim and view in here. And in order to get the flag, now I don't know what's going on with this, if this is some kind of bug or whatever, but you can literally just go in and just cat the flag, right? Without even doing any type of privilege escalation. But let's see if we can actually do privilege escalation with Vim. So let's clear all this stuff out of here. And let's see what's in here. Yeah, all right. So Vim's in here. Now, if we flip back over to the GTFO bins, we can go back and search for Vim stuff here, right? So I'm going to click on suid and use this here. Now I'm going to edit this real quick before I paste it in there. So let's clear all this stuff out, and then I'm going to change this to pi 3, like so. Now let's go ahead and try this. All right. All right, so I'm not sure what's going on here, but I mean, let's go ahead and try the cat. Let's try cat Etsy shadow. Yeah, so I'm not sure what's going on with that, but obviously it did not work. I even tried it with Vue, and I got the same thing. It didn't do anything like that. So I'm not sure if I'm doing something wrong or if maybe the machine's messed up or something like that. But anyway, we are going to continue on to the next one. And let's read through this while the VM is loading up. Cron jobs are used to run scripts or binaries at specific times. By default, they run with the privilege of the Owners and not the current user, while properly configured, cron jobs are not inherently vulnerable. They can provide a privilege escalation vector under some conditions. The idea is quite simple. If there is a scheduled task that runs with root privileges and we can change the script that will be run, then our script will run with root privileges. Cron jobs. Configurations are stored as cron tabs, cron tables, to see the next time and date the task will run. Each user on the system have their cron tab file and can run specific tasks, whether they are logged in or not, as you can expect. Our goal will be to find a cron job set by root and have it run our script, ideally a shell. Any user can read the file, keeping system-wide cron jobs under etc cron tab. While CTF machines can have cron jobs running every minute or every 5 minutes, you will more often see tasks that run daily, weekly, or monthly in penetration testing engagements, and that's what it looks like here. All right, you can see the backup.sh script was configured to run every minute. The content of the file shows a simple script that creates a backup of the prices.xls file, and that's what that looks like here. As our current user can access the script, we can easily modify it to create a reverse shell, hopefully with root privileges. The script will use the tools available in the target system to launch a reverse shell. 2 points to note. Number one, the command syntax will vary depending on the available tools. Examples, netcat or NC will probably not support the -E option. You may have been or have seen used in other cases. Number two, we should always prefer to start reverse shells as we not want to compromise the system integrity during a real penetration testing engagement. The file should look like this. All right. We will now run a listener on our attacking machine to receive the incoming connection. Looks like that with netcat, right? And let's see. Cron tab is always worth checking, as it can sometimes lead to easily privileged escalation vectors. The following scenario is not uncommon in companies that do not have a certain cybersecurity maturity level. Number one, system administrators need to run a script at regular intervals. Two, they create a cron job to do this. Three, after a while, the script becomes useless and they delete it. Four, they do not clean the relevant cron tab or job. This change management issue leads to a potential exploit leveraging cron jobs. All right. The example above shows a similar situation where the antivirus.sh script was deleted, but the cron job still exists. If the full path of the script is not defined, as it was done for the backup.sh script, cron will refer to the paths listed under the path variable in the etccron tab file. In this case, we should be able to create a script named antivirus.sh under our user's home folder, and it should be run by the cron job. The file on the target system should look familiar. All right. The incoming reverse shell connection has root privileges. All right. In the odd event you find an existing script or task attached to a cron job, it is always worth spending time to understand the function of the script and how any tool is used within context. For example, tar, 7z, rsync, etc. can be exploited using their wildcard feature. Okay, so go ahead and try to answer some of these questions here and then come back to the video for the solutions and walk through. All right, now let's go ahead and take a look at these cron tabs like so. We can see that there are a total of 4 in here. And the one we want to take a look at is going to be this backup file. So let's go ahead and crawl this stuff out. And I'm currently in the camera's home directory, and then there's the backup file. So you can do nano backup.sh, right? And you can see it's doing zip, and it's zipping up some files and stuff like that. Now if we go through and we go ahead and fix this, like so. Basically, you're setting up a reverse shell, okay? That's my IP address, and then I have netcat listening on port 2222, as we can see here, all right? So let's go ahead and save this. I don't think we need this other information here, so I'm gonna delete all of this out of here, actually. There we go. Now let's go ahead and try it. And we have to wait a little bit for it to connect back. Okay, now instead of waiting for this file to run, all I did was change the permissions on it using the chmod 777, right? And then I launched it. I had to do this 2 times. For some reason, the first time it didn't give me root permissions, but I did it the second time, and now I am root, as you can see there, right? ID, right? So anyway, let's go ahead and do an ls on here, and let's cd into the root folder, cd into home. What's in here? Let's cd into Ubuntu is probably where the flag is located. ls on it. Yep, there's the flag. So let's do a cat and then flag 5.txt. Get those contents, and that's what we need here. All right, and it says to get Matt's password for the next one here. So we're probably gonna have to do some password cracking again. All right, now remember to do that. We want to cat the etc shadow file, right? Like so, and you could, I guess, try to crack this with John the Ripper and all that, but I'm gonna see if I can do it the easy way through that Hash's website. I think I still have it pulled up here. Let's check. Okay, we do. Let's go search again, and I'm just gonna plug this in. All right, and it found it. So scroll down here. 1, 2, 3, 4, 5, 6. So that's the password for Matt. Very strong password. All right. Task number 10, we're going to talk about privilege escalation path. So let me go ahead and minimize all this stuff in here. And let's go ahead and kill this target box because we're going to have to get into a new one for this task. Terminate machine. And go ahead and fire this up and read through some of the stuff here. It says, if a folder for which your user has write permission is located in the path, you could potentially hijack an application to run a script. Path in Linux is an environmental variable that tells the operating system where to search for executables for any command that is not built into the shell or that is not defined with an absolute path. Linux will start searching in folders defined under path. Path is the environmental variable we're talking about here. Path is the location of a file. Typically, the path will look like this here. I mean, I know we saw this earlier. If we type thm to the command line, these are the location Linux will look for um, an executable called thm. The scenario below will give you a better idea of how this can be leveraged to increase our privilege level. As you will see, this depends entirely on the existing configuration of the target system. So be sure you can answer the questions below before trying this. Number 1, what folders are located under path? 2, does your current user have rights privileges for any of these folders? 3, can you modify the $ path? 4, is there a script/application you can start that will be affected by this vulnerability? For demo purposes, we will use the script below. All right, that's what it looks like. This script tries to launch a system binary called thm, but the example can easily be replicated with any binary. We compile this into an executable and set the suid bit. You can see that information here. All right, our user now has access to path script with suid bit set. All right, did ls-l. Once executed, path will look for an executable named thm inside folders listed under path. If any writable folder is listed under path, we could create a binary named thm under that directory and have our path script run it. As the suid bit is set, the binary will run with root privilege. A simple search for writable folders can be done using the following here. The output of this command can be cleaned using a simple cut and sort sequence. And you can see that here. All right. Some CTF scenarios can present different folders, but a regular system would output something like we see above. Comparing this with path will help us find folders we could use. We see a number of folders under the /user. Thus, it could be easier to run our writable folder search once more to cover subfolders. All right, you can see that here. An alternative could be the following command below. We have added the grep-v proc to get rid of the many results related to running processes. Unfortunately, subfolders under /user are not writable. The folder that will be easier to write to is probably the /temp at this time or at this point because /temp is not present in path, so we will need to add it. As we can see below, export path equals temp, and then $path command accomplishes this. All right. At this point, the path script will also look under the temp folder for an executable named thm. Creating this command is fairly easy by copying bin bash as thm under the temp folder. And we can see that here. We have given executable rights to our copy of bin bash. Please note that at this point it will run with our user right. What makes a privilege escalation possible within this context is that the path script runs with root privileges, right? So there you go. Okay, so try to answer some questions here and come back to the video for the walkthrough. Now I'm on the target machine. I am looking for writable locations. As you can see here, plug that command in here. And the one that sends out in here is going to be this home Murdoch, right? So let's go ahead and navigate to this particular directory here. So if you do cd into home and Murdoch. All right, it didn't let me copy that for some reason. Anyway, so cd into home, and you can see there's a couple in here. And if you go take a look at Matt, that's where the flag's going to be. All right, that's what we need to get to, but we can't get to it yet. So try to go in and cat the flag. You won't have permission to do so. Right. So you do ls.al on it, and you can see who's got permissions and stuff to look at it. But anyway, so let's go ahead and back out of this, and then cd into Murdoch, like so. Do ls there, and we can see test in this thm.py file. So you do file on test to get some information about that file. All right, and you can do cat on thm.py. Right, now it's doing the same thing as stated up above here, right? It's going to be trying to run this thm file, right? And there's no path variable set in there, and that's exactly what we want. So let's go ahead and clear this out of here. And if we follow along with the instructions from earlier, we can go in and take a look at the path information here, right? You can do echo then $path. Okay, now we're going to set this to that temp directory, right? Like so, copy and paste that in there. Now if we do that again, echo $path, and it should have that temp in there now. See how it's pointed to there? So let's go ahead and cd into tmp, right? Do an ls, so there's nothing in there yet. But we will need to basically get that thm file or create a file with thm and go from there. Okay, so it says thm creating this command is fairly easy by copying bin bash as thm. So let's go ahead and do that. All right, let's do echo, and then we'll do this bin bash like so. All right, and then we'll do thm. Bam, now we got that in there. So let's go ahead and edit this file. Let's clear all this out, and then we'll do a chmod 777 thm. Okay, so let's go ahead and navigate back to Murdoch's home directory, like so. All right, now the file is still in there, right? Yeah. Now let's go ahead and launch this test, and now we have root access, as you can see there, right? Because there's no path variable set, and we set the path to that temp directory, which is pointing to that file we created called thm, right? And inside that file, it's bin bash, right? And it's running as root, as you can see there, or now root. Now, if we go and cd into home and mat, all right, now we should be able to cat this flag and see the file contents, txt. Bam, that's exactly what we needed. All right. And the questions are, what is the odd folder you have write access to? And we did that find command. We discovered that home Murdoch is the odd one out. And we exploited the $path vulnerability, as you saw there. and we got the file contents of flag. So let's go ahead and kill this machine and continue on to the next task. We're going to be talking about NFS. So let's go ahead and start this up. Privilege escalation. NFS. Privilege escalation vectors are not confined to internal access. Shared folders and remote management interfaces such as SSH and Telnet can also help you gain root access to the target system. Some cases will also require using both vectors. Examples: finding a root SSH private key on the target system and connecting via SSH with root privileges instead of trying to increase your current user's privilege level. Another vector that is more relevant to CTFs and exams is a misconfigured network shell. This vector can sometimes be seen during penetration testing engagements when a network backup system is present. NFS, which stands for Network File Sharing. Configuration is kept in the etc exports file. This file is created during the NFS server installation and can usually be read by users, and this is what it looks like here. All right, the critical element of this privilege escalation vector is the no root squash option. You can see above. By default, NFS will change the root user to NFS nobody and strip any file from operating with root privileges. If the no root squash option is present on a writable share, we can create an executable with the suid bit set and run it on the target system. We will start by enumerating mountable shares by or from our attacking machine. So we're going to do this as soon as this continues booting up. And as you can see, I've already done that here. We will mount one of the no root squash shares to our attacking machine and start building the executable. So we'll do that here in a moment, but this is what it looks like. As we can set suid bits, a sample executable that will run bin bash on the target system will do the job, and this is what it looks like here. Once we compile the code, we will set the suid bit. All right, so they compiled it. There you go. Set the suid bit with the plus S, NFS. All right, there you go. You will see below that both files, nfs.c and nfs, are present. On the target system, we have worked on the mounted share, so there was no need to transfer them. All right, so that's what it looks like here. Notice the NFS executable has the suid bit set on the target system and runs with root privileges. All right, so let's answer some questions real quick. How many mountable shares can you identify in the target system? And we can see we have a total of 3, so let's go ahead and type that in. How many shares have the no root squash option set? And we can do that with, remember it said it was the cats, etc, and then exports. I believe that was the name of it. So if we go in and take a look here, and let's see here, no root squash, so that's 1, no root squash, 2, and then no root squash 3. So all 3 of them have that set or enabled on it. Gain a root shell on the target system. We'll do that here in a moment, and then get the flag. So go ahead and try to do this yourself, and then come back to the video for the walkthrough. All right, let's get down to business. First things first, on my attacking machine here, I am going to cd into this temp directory. All right, as you can see here, and I am going to make a directory called, let's do shared folder. All right, and now I'm going to cd into that directory. All right, now I'm going to mount that directory like so. And I'm mounting my temp directory from my attacking machine to this home Ubuntu shared folder on the target machine. As you can see the IP there. So let's go ahead and mount it like so. There we go. It's mounted. Now we're going to go in and create this suid bits file and such inside of this directory. So let's do nano, and let's just call this nfs.c. Okay, now I'm going to basically copy and paste from my notes here. This is the exploit stuff here. So copy this over and paste. Not sure what happened here, but anyway, I managed to get this file compiled from this .c file. Now it's called NFS, as you can see there, and did a chmod plus s nfs on that file. listed it out there so I can see the permissions and such. So let's navigate back over to the target machine, and you can see the files in there now. And if we go ahead and try to run this, so let's do / and then NFS. All right, now I am root, as you can see there. So ID, who am I? Root. Okay. And now we can find that flag. Now the flag is going to be located in this home mat directory. As you can see there, I'm in home mat directory, ls, there's the flag, cat at the flag, and got the contents of it. So let's continue on to task number 12 here. And we're going to talk about this capstone challenge. Let me go ahead and kill this target machine. And let's go ahead and start this one up and read through some of this stuff here. It says, by now, you have a fairly good understanding of the main privilege escalation vectors on Linux, and this challenge should be fairly easy. You have gained SSH access to a large scientific facility. Try to elevate your privileges until you are root. We designed this room to help you build a thorough methodology for Linux privilege escalation that will be useful in exams such as OSCP and penetration test engagements. Leave no privilege escalation vector unexplored. Privilege escalation is often more an art than a science. And here's the credentials to SSH into that target box. What is the contents of flag 1? Contents of flag 2. So go ahead and try to do this yourself, then come back to the video for the solution. Remember, you might need to do some enumeration to try to find some potential privilege escalation paths. Okay, so let's go ahead and try to figure this out. We need to find flag 1 and flag 2. First things first, let's check out this directory. We got Leonard, Missy, and root flag. We can't access these other ones, so if you try to cd into Missy, access denied, cd into root flag, access denied. All right, you can do a sudo -l, check your permissions, and you probably don't have any permissions. Yep, they do not have anything. All right, so we need to find privilege escalation pathways. We can do that using the find command, like so, to find potential things we can exploit on here. And remember, if we flip back over to GTFO bins, we can use this file read. So that's what I'm going to use here. This is like I guess the shortcut method or whatever. But anyway, this is the quickest way to figure this out. So first things first is I'm going to copy and paste this over, like so. There we go. Decode, bam. We got one of the file contents. So I'm going to go ahead and grab it. That was for flag number 2. Okay, now if you want to get to flag number 1, basically you need to be able to escalate privileges into Missy. Now to do that, you're going to have to use John the Ripper and such. So first thing you want to do is go in and find that you want to read the shadow file so you can get the file hashes from the machine here, and I've already done it here, so I'm going to up arrow till I find it. There we go. So now what you want to do is copy these hashes out of here, and you're going to be cracking them with John the Ripper, which I've already done here. All right, so flip back over to my attacker box. As you can see there, I got 2 files in here. First, the file you're going to create is pass.txt, where you're going to paste those hashes inside of there, and you need to create a file called shadow.txt, and then after that's done, you're going to use the unshadow and then the name of the file, which is pass.txt, that has the hashes in it, and then shadow.txt, and that's going into this crack.txt file. And you can see that here, it catted that file, it's got those in there. And then use John to crack that file. You can see that I got the password of Missy. So Missy's password is capital P in password and then the number 1. So switch back over here and clear all this out. All right. And let's go ahead and switch to Missy. All right, password is password, capital P, and the number 1. There we go. Now we are Missy. So if we do ls, cd into Missy, cd into, I guess, documents. That's probably where it's going to be. ls. There we go. Now we can cat that flag and get the last flag for this, flag.txt. All right. There we go. And we are done. So it looks like you can use a combination of John the Ripper and also using that that information from GTFO bins to exploit that the base 64, right, to get those password hashes and such, and then crack them with John the Ripper. So everything we've learned in this entire room, you can apply here and do this escalation pathway to get these flags. And that wraps up this video. This was probably fairly long, but hopefully you guys got some valuable information. If you did, be sure to like, comment, and subscribe. As always, thank you all for watching. Have a nice day, and be sure to check the description area of this video for more resources to look into.